Okay, this is part 2 of the climate change video. First part basically went over the science and how this all works. Now I sort of want to talk about some nitty-gritty stuff about how this is all how this all plays out in long time spans, because this is kind of an interesting thing to think. And you don't need to really watch this unless you're interested in how climate change has impacted the course of history a little bit and some of the theory here. This is kind of interesting. All right, so what I'd say here is that I showed you how temperatures have been measured. This is a direct measure of temperature by using thermometers, right? So this is basically thermometers placed around the Earth measuring temperature increases, right? And so this is a pretty good measure of what actual temperature is on the Earth. And here's a CO2 increase, also directly measured by instruments, right? Here's a direct measurement of temperature of the Earth by a satellite, like measuring infrared radiation coming off the Earth. So this is a good measure, but this is a short 1979 to 2021, right? This from using instruments actually goes back past 1960s, go back further. It goes about 1850. We have a good record. And there's some areas on the Earth where you have records going back further, like England, you have records going way back, right? But there weren't thermometers everywhere that you could actually use to reconstruct temperature of the Earth until about 1850 or so, right? So this measure is a pretty good probably measurement of land temperatures since about 1850, right? And this is again an average of temperatures all around the world, right? Giving you this kind of one measurement for the temperature of the planet. Okay, now what happens if you go way back, right? So if we look at temperatures going back past when we had instruments, you have to find another way of measuring temperature, right? So the way you do this is actually, in a lot of these cases, is for really long time spans, like millions of years. You use ice cores taken out of like Antarctica or Greenland, ice cap, and you measure changes in oxygen isotopes, oxygen 18 versus oxygen 16, right? And the change in those isotopes is a measure of temperature, right? So a lower delta 18O measurement here is a higher temperature, right? So this graph is showing 0 to 5, which means increase in delta 18O value, right? But this means higher temperature up here and lower temperature down here. Okay, so this reads sort of like how you expect to read a temperature graph. So this is a measure of temperature. Now this is a proxy. We talked about this, right? Proxies are ways of measuring temperature that are not directly measuring temperature, but the effects of temperature. So this actual oxygen 18 to 16 ratio is a proxy measure of temperature. Okay, so if we go back 60 million years, right, the temperature of the Earth was quite a bit warmer, right? As you can see, it's like it's up here high, and then it goes down over like the last 60 million years. And then we get now the scales change here on the x-axis, and we start seeing the temperatures move around a lot, but they're coming down, and then start oscillating like wildly, right? Until we get to now. We're right in here where it's warm, right? This is an ice age, warm, ice age, warm, right? These are about 100,000 year cycles. So we've had a ice age about 100,000 years ago. We've come out of it, and we're now in a warm interspace between ice ages, right? Then there was another warm period, and then another ice age about 200,000 years ago, and then a warm period, another ice age about 300,000 years ago, and then a warm period, another ice age about 400,000 years ago, another ice age, and another warm ice age about 500,000 years. You can see the pattern, right? So that's been happening over the last couple million years of the Earth's history. Why this is happening this way, I'm not sure people know. But this is like there's a pattern settling in here of the recent past that seems to be becoming apparent, right? Now, if you even break this down, this like span right here, and zoom in and look carefully at temperatures versus CO2, you see this interesting pattern. Here's the temperatures over time. So cool, ice age, warm, cool into an ice age, warm, cool, then come a weird thing here, cool, ice age, warm, cool, ice age, warm. And now we're right in here, right? So this warm period that we have now has been actually going for 10, 20, 30,000 years. Usually they peak and then drop. This one's flattened out. And there's an interesting question as to why. And that's a longer conversation. I'll maybe just say something quick about it in a minute. But you can see climate's really variable. And the difference is, in these ice ages, if you look out the window of your dorm room, or if you live in the Northeast United States, that was all ice in these ice ages. So like even back, 40,000 years ago, 30,000 years ago, there was an ice cap on top of North America that looks like a mile of ice just sitting right on top of Massachusetts, or close to Massachusetts, right? And then it warmed and that ice all went away. And now we have this climate that's like what we have now, right? So this change here of a few just like degrees of temperature, right? 8 degrees temperature was enough to go from a mile of ice on Massachusetts to nothing, to the climate we have now, okay? So it's something to keep in mind. There's like huge effects. These temperature, even a few degrees temperature change can really have a huge impact on what the climate looks like. All right, so this is a repeat of what I just showed you. So and that's a repeat. Okay. All right. So okay. So one of the questions is like, what's the forcing that causes these shifts from warm to ice age, warm to ice age, warm to ice age? And people have actually looked at this, and they figured out that there's this shifts in the orbit of the Earth that brings it closer or further away from the sun, just a little bit, to cause these changes. And so these ice ages seem to correlate with the Earth being a little bit further away from the sun and having a little bit less energy. Watts per meter squared is a measure of energy incident on the Earth's surface, right? So when it's cooler, we tend to get an ice age, right? When it's warmer, we tend to get a warm, and there seems to be a correlation there, right? Although it's a little hard to see here, but you kind of see it emerge, right? So warm periods seem to correlate with more solar radiation incident on the Earth, which makes some sense, right? And then ice ages tend to be correlating with less, right? So the Earth wobbles kind of as it orbits. If you read this, you'll see. You can go back to the PowerPoint and look at this, right? So we're here, right? And actually, we should be going into an ice age. We're in a stage of the wobble where the orbital forcing would say we should be cooling, and yet we're not. And this is actually kind of interesting because every previous warm periods have actually cooled off, and this one's lasting. And there's some theory to suggest that what's happened here is that that humans, the development of agriculture has actually caused humans actually producing greenhouse gases, which have caused the climate to stabilize and become very good for human activity, because just by accident of agriculture and forest clearing and so on and so forth to support agriculture, that we've actually caused the climate to stabilize, and we're not going into another ice age like we should have been because of greenhouse gases, right? So this is actually really interesting because it really suggests that humans inadvertently have changed the climate to be optimal for their own evolution and survival and reproduction by accident, just set by happenstance, right? Kind of interesting. All right, so we'll skip this. Okay, so again, I just have like 1,000 of these. All right, so now we can look at even a more closer level. So let's even look more recently. So here's 20,000 years and climate temperature over time, right? And this is temperatures relative to an ice core temp in I think probably Greenland, right? So this is why it's so cold. But you can see now over 20,000 year span that we had a really cold period here, where this is a time when modern humans are really getting going, moving around the planet a lot, and developing agriculture is developed in here somewhere, right? And then we got this, so this is cold, it's the end of the ice age. End of the ice age started coming up here. So we had ice age, we had this kind of warming interlude, and then back in the ice age for a bit, for about 5,000 or 6,000 years, and then it started warming up. And now we're in this period here where we've warmed up, and it's kind of stable, right? And again, the theory here is that agriculture, forest clearing stuff is actually what's made this difference, right? Now, we can actually even zoom in here and look and see, okay, we're right here at the end, right? we're actually coming out of a cool, kind of slightly cool period. It's called the Little Ice Age. It happened within historical time frame, the mid 19th century, right? And then we had the medieval warm period, which is right here, right? It's a little bit warmer. And that was actually right the 1200, 1300 to about 1700, 1800, somewhere in there, right? Warm, good for European, at least the European civilization, although I think it happened worldwide. It's actually pretty China, Asia, Africa too, probably, right? South America, right? But then it cooled for a while, and that caused some issues. And now we're back into a warm period again, warmer, right? So we're right in here, and historically, and what we can measure is right at the tip here, okay? So this is blow this up yet again, right? And we can see this longer time span. Here's more recent, right? So 1000 AD, warm, medieval warm period, so like 11, 12, 1300, 1400, and then, okay, sorry, I had the time off a little bit, but it was warmer in the medieval period, and then it cooled off into the 1500s, 1600s, 1700s, and it stayed cool until 1900s and started warming again, right? And this is going to like, this is showing like 1950 or so, 1960 or so, and then it's increased even more now, right? So even in these time frames, climate's been variable. And you know that back in these times, right, humans had no influence on climate, right? We weren't producing CO2 gases because we didn't evolve yet, and we had no technology. So humans not involved in this, and yet climate is wildly variable, right? And even here, we're not really doing a whole lot except for maybe the agriculture piece, and it's controversial, right? But the climate's still pretty variable on this like smaller scale now, coming out of a major ice age into a warm period, but then it's still variable, right? Bouncing around, moving, right? And only right in here, we actually producing a lot of CO2 gases, right? So our impact on climate is only happening at the end here, right? From CO2. And the rest of the stuff is something else going on. And this is very controversial. Like, is this real, for example? Is this a real effect? Is climate, is this global, or is this just localized to Europe, for example, right? There's all sorts of controversy about this. Still see papers being produced that argue this doesn't exist. This didn't exist for real, right? But then other people would argue otherwise. And the data seems to suggest that these things really did exist, but it's controversial. Okay. All right, so let's skip that. Okay, so here's the last 2000 years, right? Temperature reconstructions. Most of this is not measured by direct measurement with thermometer, but through proxies. And a lot of these are tree ring proxies, like tree ring growth, like I mentioned before. And here you can see, you know, lots of these proxies have been put together in one graph and sort of superimposed, and then the green is kind of the average, right? And so you can see that, yeah, there's some things going on. There's variability here. The climate's never been stable, right? And it's never going to be stable. So we're right in here. I kind of pass this a little bit, right? So this is the last century, right? We've got this increase in the 40s and 50s, and then a decrease, and then up to 2000, and then a little decrease here, right? So this has been, climate's variable, and whether humans have influenced or not, well, the recent changes are new, right? But they're superimposed upon a climate that's already really, really variable, right? So just keep that in mind. It's important to keep in mind, right? So here's another representation of that, just smooth. Okay. Okay. Now you can reconstruct temperatures using tree rings and various things, and then what people sometimes do is fuse that onto measurements of temperature. And there's a problem with that because these measurements of temperature are not exactly the same as these measurements of temperature using thermometers, and so they don't exactly necessarily. You got to make sure you make a distinction between them because they don't necessarily match, right? So this is a little bit sketchy. There's the way you measure temperature is not perfect with these proxies, and then comparing them to thermometer temperatures is not exactly reliable, right? Okay, so over the past 660 years, there's been about 0.8 degrees Celsius temperature increase, right? And now, one of these questions is like, how much of an effect is that on climate? Like, how much difference in climate in 1850 versus now? Well, it's definitely colder back then, right? So I think you hear more reports of, or more descriptions of heavier snows and nastier temperatures in the winter and stuff in Europe and stuff, right? Than it is now, right? So there's certainly an effect, okay? How much of that's actually due to climate, to CO2 increases versus other variables, right, that are causing these? We don't know, right? So this is why there's a lot of research going on this, a lot of controversy. Okay, you can definitely see though that back in the, and this is 1978 to 2019, you know, it was cooler back in the 70s, right, or 80s, and now it's warmer, right? So you know, temperatures warmed up. Okay, definitely. Why is a good question. CO2 maybe. Here's measurements of temperature versus CO2 increases, right? And we can see since 1998 to 2008, right? Here's the CO2 increases, measurements of temperature. They don't match very well, right? In this little block of time. This is only, you know, what, 10 years, right? So it's not a really good, clear, but they don't always match up. So this is, CO2 is not a perfect predictor of temperature. Okay, I think that should do it for this. Yeah, okay, let's stop. So the point, the end point, right? So what does this mean? Temperature, climate variation on Earth is on the Earth is constant. In other words, the temperature is constantly changing, right? Not that the climate is constant, but the variation is constant. There's always variation, right? And constantly changing over both long and short terms. Earth never has had, or probably never will have, a totally constant climate, especially over longer time spans, hundreds of years or longer. Even in fairly recent time frames, last 2,000 years or so, before widely accepted climate change effects due to greenhouse gas emissions, climate has been variable, like this Roman climate optimum even, right? Which I didn't talk about. The medieval warm period, the Little Ice Age, right? And you can go back and look at the literature. I mean, there's like stuff on this, that this is real. Like people are writing major novels in this period. They're talking about cold temperatures, the Thames River in England freezing routinely in the winter. Doesn't happen anymore, but this time it did, right? These variations result in some pretty major impacts on human civilization. And actually, we have a whole course on this, interdisciplinary studies 507, which is called Natural Causes. This is a course on this. So we teach this in the winter, me and Ms. Doheny. So you want to think about that if you're an upper. Take that next year. Pretty interesting class. Recent warming has been linked to human-caused increases in greenhouse gases, CO2, methane, nitrous oxide, and stuff. Right? We know that these cause global warming or increase in temperatures. Right? But the effect they have and how they interact with climate, natural climate variation, is still unclear. Right? And so keep that in mind. Right? Okay, we're gonna stop there. And let me kill this, and hope you enjoyed that.